is Bill Footen. Welcome to Stats 1 again. We're all the way up to lecture 9, and I'm calling this the elastic Gauss. And if you hear a lot of noise in the background, I think we got a fire going on in the Bronx here somewhere. Elastic is going to come up. All right, so elasticity or sensitivity. And sensitivity analysis is one of the core foundations of any good analytics. We're going to pose the question this time, though, of revenue as opposed to just units sold or sales, as some people might call it. And we're still looking at Q5. What can we infer about the range and the plausibility of potential outcomes in Q5? And this will all be just given levels of revenue in this particular case from quarters 1 to 4 across 4 regions and 6 products, 2 different product lines. Remember, we're dealing with Lancaster and Star, those 2 lines. But this time, because we have revenue, we need to have price. Our data will have to have price in it if we're talking about revenue. Why? Well, that's how we form hypotheses. There's something about the quote unquote science in this case, the economics. And important digression that we would put a wireframe around would be, well, what is the goal of our organization? If it's a not-for-profit, it might be saving lives. How do we do that? Well, we need to bring things in and we need to push things out. What are we bringing in? We will be bringing in donations. We'll be bringing in customers, patients, clients, people who need our services. We'd be pushing out, we're putting out services. We might be putting out products as well, books and training materials and things like that. We need assets, probably intellectual assets for the training materials. We might have particular approaches and frameworks that we could be considering assets. We might have to have an office facility, brick and mortar facilities, all sorts of assets that might be needed. But in our particular case here, it's a simple product. And it's probably shareholder value, although we usually talk much more about all the stakeholders and their value. What drives that? So this is a driver model, and in a purely financial sense, which has lots of strategic and tactical implications. We must have revenue growth. We must be able to contain costs. We will have assets involved, and there are a variety of other categories just put under the rubric of management. Now, Accenture, Capgemini, Deloitte, lots of organizations and consulting organizations, McKinsey, small m, will have some sort of framework like this. You will see this in the back of most financial statement and analysis books as well in finance. But the driver model basically says you can decompose the value that you think you are providing your stakeholders into multiple categories. And these categories can communicate with one another. But in our case, we're doing a very, very simple hierarchy. So this is like level 0, this is level 1. And a good example of this is at Deloitte. And you could probably Google their approach called a value map. I know I helped build one. I think there's one in the boardroom of Merck still. Maybe not, maybe they finally took it down and dusted it off and put it in a closet, who knows. But revenue growth is what we have been talking about here. We have a couple of different drivers here that we're not even talking about, new and existing customers, for example. There's one other, and that is pricing. And again, pricing, going from the gross price to the net price, what's in between the gross price and the net price is all sorts of marketing programs. And at some companies, there might be 20,000 of these in a given quarter. What are these marketing programs? Well, they're the circulars that you get in the newspaper. We still do that, apparently, from the local grocery store. That is a marketing program, and it's designed to attract you to the store. Okay? It's not pushing you there, it's attracting you on the theory that you're looking for same quality, lower price. That is the idea. And now when we introduce price, we're now introducing the idea that there must be a relationship, and for new and existing, okay, there must be a relationship between units sold and price. And in fact, we can draw that relationship typically from microeconomic theory and some notion of how much utility a set of products, given a budget constraint, we can use some mechanism to derive something we will call a demand curve. And as you all recall so very well from your economics background, or just from the lemonade stand that you might have wasted on all the adults in your neighborhood as a child, there's probably a downward relationship between price and quantity. And because this is an analytics segment here, using a pretty well-founded idea about yes, the economics. I wouldn't necessarily call them laws, but I would definitely think about them more like behavior maps more than anything else. And if we increase the price, the demand for whatever product goes down. If we decrease the price, the demand for the product goes up. One way we can express this mathematically is say price is equal to some constant A times quantity to the B power. This is a power law. B is almost uniformly less than 0. And you can solve this equation, which I suggest you try to do. If you divide both sides by A and raise both sides to the 1 over B power, okay, well, it's B times 1 over B. You can isolate Q in this particular way. Okay, so you can work back and forth between a price dominant response or a quantity dominant response. This is more Marshallian approach. The flip on this is Marshall, of course, is English, British empiricism, really strong. On the continent, they tend to put quantity on the vertical axis, as in Monsieur Cournot. Yeah, okay, too much economics. Well, I am an economist, so you get this kind of an idea. But one of the interesting things that you can show is if you take the logarithm of P, that will be equal to the logarithm of A plus B log Q. If you remember your logarithms, and the logarithm of a product is the sum of the logarithms, and the logarithm of something to a power is B times the logarithm of that thing. That thing in this case is Q. When we start thinking this way, B can be approximated as the percent change in P divided by the percent change in Q. B is elasticity. how sensitive. If there's a 10% increase in Q, there is a B% decrease in P. And that's the idea of sensitivity. And that's uniform across everything. Hooke's law, which was the elasticity of a coil, a spring, is done very much in the same way here. And there's a modulus and all of the science of physics. Okay. How sensitive are you to a particular stimulus of any kind, a psychological approach, a psychometric approach? All of that's in here. So these are all the things that we are thinking about. We have a driver model. We have a relationship that's supposedly negative. For example, if B equals -2, a 10% increase in quantity will mean a 20% decrease in what? Price. Okay, that's the idea behind it. Now, later on, you will be able to use exactly this relationship, for example, in finance, where logs are used to create returns, and the return on a stock is equal to an alpha plus a beta times the return on the market. Very, very raw approach. And there's a lot more to that. And there's a whole equilibrium pricing model around that. But that's in finance. Okay. Here we're looking in other kinds of markets. Okay. So, okay, we just had a nice discussion about form. To form is form hypotheses. So we might want to look at something we would call the correlation between price and quantity. That'll be much of our next stop. But if we think about correlation, and many of us have prior to a course like this, where we look at, let's bring this back over here. We look at different levels of quantity demanded, units sold, and look at the prices. We might find a scatter of combinations of prices and quantity, which if we were to draw a line through them, and there's some notion of the best line that we can push through there, according to some sort of criterion, we might say there's a general downward movement or trend. That line now becomes a trend. And we would be estimating A, and we would be estimating B from the data. But immediately, what we can do is find the correlation, which also describes the relationship up and down between P and Q.